Hello friends, in today's video I am going to discuss 885 interrupts. For that I have written certain instructions here. These instructions are written at address XXYY and onwards. Okay, here only two addresses are shown. First is XXYY, it is any random address, and at that address I have written instruction EI. Then at next address I am written this instruction, and then onwards address is increasing. All right, and at some other address, that is YYZZ, I have written different set of instructions. That means there are two programs. You may say this is program 1 and this is program 2. When this program will be running, when microprocessor will be running this program written at address XXYY, then take a look. This program will be always in a loop. That means after running this instruction, and up to this instruction, and then here it is written JMP back. That means after running this instruction, our control microprocessor will jump to address label back, and always microprocessor will be in a loop and it will not come out of loop. So, but we have written another program at some different address. So what is the method by which we can run this program also? That means first of all microprocessor is running this program, and we want, on happening of certain conditions, that microprocessor will run these set of instructions. So there is a provision available in every microprocessor and microcontrollers that we call interrupts. So interrupt is a provision by which we can run another program. That means one program is running, microprocessor will be always in a loop, but after occurring of certain conditions, microprocessor will be forced to run a different set of instruction, and after running this program, microprocessor will return to the first program. This first program, that is program 1, is called main program, and this second program, program 2, is called interrupt service routine. Now this address, that means address for main program, you may write our main program at any address. That means we may write our main program at 000h2 FFFH, provided if you are not going to use interrupt. That means if you are not going to use interrupt, then you may use all the available memory spaces to write these instructions. But as in this program we are going to use interrupt, for this program we will have to leave the certain addresses that is devoted to the interrupts. Okay, we will talk about it, that what are those addresses. So after leaving addresses dedicated to the interrupt, we may write this program anywhere in the whole available memory. Okay, but these instructions, that means this address, we can't use any of available memory addresses to write these instructions. We have only certain available addresses where we may write our interrupt service routine. Those are 0000H, 0008H, 0010H, 0018H, and similarly so on, it will go to 0038H. And another addresses that we have, it is 003CH, 0034H, 002CH, and 0024H. Here total 8 addresses are available where we may write our interrupt service routine, and here only 4 addresses are available. That means total available memory addresses are 12 addresses where we may write our interrupt service routine. And these addresses belongs to, and or we may say these addresses are assigned to certain instructions and certain pins. Like this side of addresses are assigned to pin RST0, this is RST1, this is RST2, this is RST3, and up to RST7, and in between there will be RST4, 5, 6, and this is 7. Okay, and these addresses are assigned to RST 7.5, RST 6.5, RST 5.5, and RST 4.5. This RST 4.5 is actually trap. RST 4.5 is the another name of trap. Okay, so this side all of these are instructions. These are restart instructions, RST instructions, and this side all of these 4 are pins of microprocessor. So now if you want to write this program and we want to use interrupt, then obviously we will have to leave these memory addresses, because these memory addresses will be used to write interrupt service routine here. Alright, so that means if we want to use interrupt in our program, then it will be better to leave these addresses, and last address that we can see here is 003ch. That means leave some space after 003ch, and after that start writing this main program. Now these RST, that means restart, these restart instructions, these are instructions. That means if somewhere in my program I will insert any of these instructions, then simply microprocessor will jump to the corresponding address. For example, if I insert here RST2, then what will happen? Microprocessor will run this instruction, then this instruction, and when it will encounter RST2, then microprocessor's control will be transferred to the address 0010H. Okay, that means now we may jump to another address by using instruction, that means by using software. That's why all of these are called software interrupts. Remember what I said? If you will insert any of these instructions in your program, then microprocessor will jump to the corresponding address related to the written instruction there. Like here I have written RST2, so when microprocessor will encounter this instruction, then instead of going forward, it will jump to the address 0010H, and microprocessor will perform the instructions written at this address, and after completing these instructions it will return to the main program, and for that we will have to use RET instruction. We will be discussing it. Now for this side, remember what I said, these are the pins of microprocessor 8085. That means if you want your microprocessor to jump to these addresses 003C, 0034, 02C and 024, then you may achieve this only by some physical signal changes. Physical signal changes means, as you can see, these are the pins of microprocessor. This is our microprocessor, and assume that this is RST 7.5. So if a signal change will be here, that means it will be a rising edge. If a rising edge will be there, then microprocessor will leave the current instruction whatever it will be running, and it will jump to the address assigned to RST 7.5, and that is 003CH, and microprocessor will run the instructions written at that address. So because microprocessor may jump to these addresses only by some hardware changes, like this pin is going from low to high, and this will be achieved by some hardware, like some sensor may be connected here, or simply you may have connected some switches here. So because of that particular hardware, the signal level at this pin is changing, and because of that microprocessor is changing the sequence of programming. So because all of these are achieved by hardware, that's why it is called hardware interrupts. Now assume that here you have written this interrupt service routine at address 002CH. It simply means if you want to run this set of instructions, then simply you will have to use RST 5.5 pin to initiate this operation. That means to force the microprocessor to leave the current running instruction and jump to the address 002CH. So by now what we have learned, what is software interrupts and what is hardware interrupts. Alright, next is their maskable and non-maskable interrupts. Okay, so what is maskable interrupt? Maskable interrupts are those interrupts those can be disabled. That means if you can disable any interrupt, okay, then it will be called maskable interrupt. And non-maskable interrupts are those interrupts that can't be disabled. That means we can't disable it. That means if anyhow any interrupt is generated at non-maskable interrupt by non-maskable interrupt, then that subroutine will definitely run. As an example of non-maskable interrupt, there is only one non-maskable interrupt in 885 microprocessor, that is trap, and rest of all are maskable. That means RST 7.5, RST 6.5 and RST 5.5, and one more interrupt, that is INTR. Remember, I have not written INTR somewhere here because it is an interrupt of different category. So it is maskable interrupts, and here it is non-maskable interrupts. Next is vectored interrupts and non-vectored interrupts. Well, you can see here that these are the software interrupts, and with these interrupts an address is associated where you will be writing your interrupt service routine. Like if you are using RST3, then you are forced to write your service routine at address 0018H, because when microprocessor will be encountering this instruction, when it will be running this instruction, then after running this instruction microprocessor will jump to 0018H. So that's why you will have to write your instruction, your service routine at 0018 address. Similarly, if you are using any one of signals, these signals of these pins of microprocessor, then you will have to write your service routine at only these addresses. Alright, so that means for all the things written here above, from RST0 to RST7 and from RST7.5 to trap, we have an address where we will be writing our interrupt service routine. That's why these are called vectored interrupts. Why it is vectored? Because microprocessor knows that where it has to go. Alright, that means if microprocessor encountering any one of these instructions, or microprocessor is facing some signal changes at these pins, not some signal changes, particular signal changes, like for RST 7.5 I have used rising edge. Okay, so similarly 6.5 and 5.5, these are the level triggered, and for trap it must be rising, and at that pin for some time signals must be high. Okay, so if these type of signal changes are occurring at these pins, then microprocessor will jump to these addresses. So because microprocessor knows that where the service routine is running, that's why it is called vectored interrupts. All right, and now what is non-vectored interrupt? Well, non-vectored interrupt means when interrupt will occur, then initially it is not decided that what will be the address of service routine. It will be provided by some mean. Okay, and the example of vectored interrupts, all of these are example of vectored interrupts, and INTR is the example of non-vectored interrupt, because for INTR none of the address is predefined, although we may use any of these addresses. But remember, any of these addresses, not all the addresses. Either we may use RST0, RST1 or RST7. Any one of these addresses we may use for INTR, but it depends on how we are going to use our hardware. So from that point of view, INTR is a non-vectored interrupt, because initially we do not have any particular address where we will be writing our interrupt service routine. Now one more thing about the addresses that I have written here, that you may simply get these addresses. That means RST0, what will be address for RST0, what will be address for RST3 or RST7. Simple thing is that you have to multiply these available numbers with 8 and then convert that number into hexadecimal, and you will get these addresses. For example, if we are talking about RST2, then number is 2, and we will multiply 2 into 8 and we will get 16. But remember, this number is in decimal, so we will convert it in hexadecimal, and hexadecimal counterpart of 16 is 10H, and so at page 00 the address that we will be getting is 0010H. Similarly, another example is for RST7. For RST7, simply 7 into 8, you will be getting 56. Okay, this will be in decimal, and in hexadecimal this is called 38H. 16 into 3, 48. 48 and plus 8 is 56. So this is 0038H. So address associated with RST7 is 0038H, and here it is. Similarly, you can check for these values also. So simply for 4.5, multiply it with 8, then 4.5 multiplied by 8, you will get 36 in decimal. Okay, and 24 is the hexadecimal counterpart of 36. That means 24H is equivalent of 36 in decimal. Alright, so this is the method by which we can simply get these addresses. So we don't have to memorize all these addresses. Simply we will be multiplying with 8 these numbers, and we will be getting the addresses where microprocessor will jump to run a service routine. Next is what kind of signal changes will be there for individual interrupts. So this is our 8085 microprocessor. Okay, and 1, 2, 3, 4, 5. This is RST 7.5, RST 6.5, RST 5.5, RST 4.5, or this is trap, and this is INTR. Okay, so what type of signal changes must be there to enable or to initiate an interrupt service routine or interrupt process? Okay, for RST 7.5, at this pin of microprocessor, signal must be, at first it must be in low, that means a 0 voltage must be there, and then after there must be a transition from 0 to 1. If anyhow this at this pin this transition will be occur, then microprocessor will uh, recognizing this signal and an interrupt will be initiated. Only for HT 6.5 there must be a high signal. For high signal, if at this pin a high signal will be there, then microprocessor will initiate an interrupt process. Similarly for HT 6.5, at this pin also signal must be high. For HT 4.5 for trap, first of all signal must be low, then it must go to high, and then it must be held at high for some time. Okay, and for interrupt this is also simply if a high signal will be there, then it will be recognized as an interrupt. Okay, so remember for HT 7.5 it is rising edge. For 6.5, 5.5 and INTR, simply a high at these pins will initiate interrupt process, and for trap signal must be a rising edge plus it must be hold high for some time. Okay, this is the introduction part of 805 interrupt, and in my next video I will be explaining all the software part, that means programming part of interrupt, like how to enable an interrupt and how to write any subroutine, service routine, and I will be show you some example and same instruction, what is SIM, what is RIM, and rest of the part. So for now please like my videos and don't forget to subscribe. Thank you.